All right. This lesson is the second part of graphing. You should have already done the graphs of y equals sine and cos, and this part of the lesson will help with sine and cos a little bit if you're having trouble with sine and cos. But basically our method there for sine and cos was just to plug numbers in. We just plugged in 30, 60, 90, or in the case of radians, pi over 3, 2 pi over 3, 3 pi over 3. Or pi over 6, sorry. Pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2. And we just built the graphs manually. And we could do that with here. And I'll tell you, if you get stuck in all this and it gets a little confusing for you, you can do the exact same thing here. It will work. The only reason we're doing this a slightly different way is to get a different look at tan. And it really does explain it in the note here. It goes through all that and explains everything I'm going to explain here. But it's really hard to visualize with the note as it is. You really have to see it. So what I've done is built in this program called Geometers Sketchpad a little visualization that'll help you to try to see what's going on. And there's a lot I want to talk about here, and I won't lie, this is very, very difficult. And as you're going through it, you may have trouble with it, and you have to rewatch the video. You may have to search other videos about tan to really get an idea of what's happening here, because it's very new and very weird. So all I want to talk about is going from an angle of 0 with this triangle, so I've made the angle 0, all the way up to an angle of 90, but I'm going to talk in radians. I'm going to do both. I'm going to talk in degrees and radians at the same time. I want to talk about what happens when you go from angle 0 all the way up to angle 90, which is pi over 2. And there's all sorts of things happening on the screen. I'm going to explain them one at a time. The first thing I want you to notice is check out the opposite side. It's labeled OPP there. The opposite side of the triangle as I go from 0 to 90. It starts off, that opposite side starts off really low. It actually starts off when you have angle 0. The opposite side has length 0. And then as you go all the way up to pi over 2, 90 degrees, that opposite side essentially becomes very long. It becomes about the same length as the hypotenuse. That sort of helps you with sine or cos. Just look at sine up here. Just look at what happens to the sine ratio. When I start down here, sine starts off at about 0 because the opposite's about 0. As I get closer to pi over 2, which is 90 degrees, the hypotenuse and the opposite are almost exactly the same length until I get to pi over 2 where they are exactly the same length. And that's why when you get to pi over 2, sine theta goes to 1 because the opposite and the hypotenuse have basically become the same thing. Now, that's the opposite. We've talked about the opposite now. Let's talk about the adjacent. Adjacent does the opposite. Does the completely different thing. Adjacent starts off at about the length of hypotenuse, and then as it gets to pi over 2, which is 90 degrees, adjacent heads towards 0. So take a look at what happens to cosine between angle 0 and pi over 2. It starts off when adjacent and hypotenuse are basically the same thing, and so that's why cosine starts at 1, but as you get closer and closer to pi over 2, that adjacent side becomes closer and closer to 0, and cosine ends up at 0. By the way, all this thinking can be expended all the way around the circle, and you may want to come and look at what I'm doing right here and just watch this part of the video as we go around and watch what happens to all these things as they go positive and negative, because they're all on the screen there. It's all happening there on the screen. Well, that's not what we came for today. We came for tan. One last thing. We talked about opposite and adjacent. Notice hypotenuse. Hypotenuse as I go from 0 to pi over 2 essentially stays the same all the way on that unit circle. That is, hypotenuse really isn't something that's changing as we change the angle. So let's just talk about opposite or adjacent. Draw your attention to the left side of the screen there where tan theta is, and let's talk about what happens with opposite and adjacent. When we're at 0, opposite is basically 0 and adjacent has some value, and I'm trying to get it right on here. I've made the radius of this circle happen to be 1, so it's always 1 when it's there. And when I hold it right there, do you see the opposite is 0 and the adjacent is full length? It's 1 there. And that's why at 0, tan theta is 1. As we move up along here, tan theta starts getting bigger and bigger because the opposite side is getting bigger and bigger, and the adjacent side is getting smaller and smaller. Just watch that part again. Let's see that. As I go along here, the opposite side gets longer and longer. You can see it in the picture, but it's also being measured over there on the left side. The opposite side gets longer and longer, adjacent's getting shorter and shorter, and the result of that is if opposite's getting larger and adjacent's getting shorter, this opposite over adjacent is going to become larger and larger. an interesting moment comes up here right when I get to 45 degrees, or pi over 4. When I get right to there, oh, I've gone too far. Gotta find it here. It's right about, here it comes, here it comes, here it comes. Right about there. It's hard to get it right on. Right there, right at 45 degrees, opposite and adjacent become the same, and tan gets to the number 1. But unlike sine and cos, which stop at 1 and come back down again, it keeps getting bigger and bigger. And watch how big it gets. It just gets, the closer I get to pi over 2, which is 90, the closer I get, it gets bigger, it gets bigger, it gets bigger. There's a limit to what I can handle here with my mouse here just to get it really close. But look at 17, 23, 29, 30, 41, 66. It just gets really giant, 94. In fact, it goes all the way to infinity. Because right there, if I can nail it, I can't get it to stop there. But if, look there, that's a very interesting moment. Look at the screen saying that adjacent 0. It's not actually 0. It's just rounded it to 2 decimal places. I can't get it exactly on 0, or I get an error here. It's actually 0.000001 or something like that. But just imagine if it was 0, then we'd be 1 divided by 0, which is undefined. And that's what I want to tell you about. That's my big conclusion in here. As I go from 0 to pi over 2, from 0 to 90 degrees, tangent starts off at 0 and gets bigger and bigger and bigger and bigger until it goes to a moment where it's undefined. There'll be a vertical asymptote on the graph of tan right there at 90 degrees, right there at pi over 2. Then it starts coming down out of there. Big negative numbers, and the opposite starts coming down, and it heads right back towards 0, but from the negative side as well. So that really gives you a hint on the next part. Okay, you may have to re-watch that again, but that's supposed to be a good explanation of what it's saying right here in your, that should answer, what is the value of tan x when terminal arm lies on the horizontal axis? What happens to the terminal arm lies on the vertical axis? And that's where we get that vertical asymptote. And then I also did what happens when you go from 0 to pi over 2. As you go from 0 to pi over 2, whoops, tan goes from 0 and gets bigger and bigger and bigger and bigger until it gets to, it just goes off to infinity. And then what I'm going to do, so that you can watch this part of the video, I'm going to go slowly around and you can re-watch this part of the video again and again to do the other parts of it, is just watch what tan does as I go around here. As I get to pi over 2, it goes really, really, really big. At pi over 2 it would be undefined, and then it starts at negative, big negative numbers, and comes down, comes up, sorry, all the way up to 0, and then keeps getting bigger and bigger and bigger and bigger and bigger until it gets to another one of those infinities, another vertical asymptote. Then it switches over to negative again and comes back. So really, it does the same thing twice. It starts at negative infinity and goes up to positive infinity up here, and then it starts again at negative infinity and goes to positive infinity right there. The important thing are the asymptotes are at pi over 2, which is 90 degrees, or at 3 pi over 2, which is 270. Okay, just as I wrap up here, that's supposed to help you with the second part of that. What's an assignment? You usually do that as an assignment in class, but if you're doing it on videos here, we just want to be able to fill out those graphs and then check them with something like Desmos to make sure that you've got them looking right and that they have the features that they're supposed to have. But I don't want you to freak out about this. This is just supposed to help you learn about why sine, cos, and tan are the way they are. You can go back to your sine and cos graphs and look at, as I go around the circle, you can look at those angles and look at how they compare to what you got on your graph. And the sine and cos is happening on the right hand side there, and you can follow them all the way around and re-watch that part of the video. Keep in mind that this number here, the number of radians, is in a decimal. So like when I was at pi over 4 up here, it's if you type in your calculator 3.14 divided by 4, you'll get the 0.78 there. So you got to convert those over to decimal to match them up with the radians that you know from before. But my last comment on this, if this is any trouble for you and you just want to type in numbers and memorize tan, that is okay. This is just supposed to be some extra learning here and really understand how tan works for future lessons and so on. Try that out. Let me know with questions, any trouble you're having with all of those things. Compare with other videos and compare with Desmos and see if you can really get to know the graphs of sine, cos, and tan. And that's all for today. Have a great day.